to issue not any particularly new concepts, but look at applying all of the things that we've learned, or many of the things that we've learned, into one sort of application. And like many of the things in this course, it'll be sort of data-driven. So I dug up online a couple of CSV files. One is called countrycodes.csv, and if we take a look at it, we see that it is a list of alphabetical list of all of the countries in the world, or at least it was a complete list at some time in the recent past. CSV file, so meaning we think that it's one of these things that's separated by this sort of into columns by some sort of delimiter, and we can kind of guess what the format is from this, looking at the first little bit. It looks like there's the full name of the country, and then the delimiter looks like it's a semicolon in this case, and then there's a 2-letter code, which is the 2-letter country code, and a 3-letter code, which is the 3-letter country code, and then a numerical code, which I guess is some code for countries, but I've never seen those used, and I'd be leery about using those. Okay, so that's one of those files that I have, and there's 243 entries in it, which seems like a lot because I didn't think there were that many countries in the world, but we'll see what that is. Maybe some things appear there more than once under different names. And the other file is called worldcitiespop.csv. And it is another one of these CSV files. This time the delimiters are commas, and it looks like the following. So we've got a 2-letter country code. We have a name of the city, and looks like all underscores, or not all underscores, all lowercase rather, and then maybe a bigger name of the city. So, and maybe this first version of the city name is supposed to be straight up ASCII, and the second version, if you look here, it looks like there's some weird accented characters, so those might be something we can use or not. Then there's a number, not sure what that is, and then some other stuff that looks like, anybody know what these other two numbers are? Like this one, this one. Any guesses? Yeah, so it looks like they're all kind of close together, right? 42.4, 1.5, 42.4, 1.5. So all of these things close together, and that makes sense that these might be coordinates because, right, these things are sorted by country, and so the cities within a country, especially a small country, should have similar coordinates. So maybe that's latitude and longitude. And we can maybe take a look at some things we know. So if I look in that file for all the occurrences of Ottawa, I see one in Canada. And what have I got here? This looks like the right latitude and longitude for Ottawa, these last two numbers. This number here, I suspect it's a population, and this file is a bit old, so the population is only 800,000. And then there's this 2-digit number, I'm not sure what that is. And then the other stuff is as we expect. Okay? So And this file has, it's a big one. If I count the number of lines in it, which should be the number of cities, it's about a little over 3 million. Okay. So this is a pretty comprehensive list of the cities in the world at some point in the recent past. I won't say it's perfectly up to date, but it's substantial, and it's it's a real chunk of data to work with. So here's what I would like to do. I would like to turn this into an application, turn these files into an application where I can search for a city by name and get whatever information is available about that city. So if I know the city's population, I can see that. If I know what country it's in, I should be able to see that. And maybe the latitude and longitude if we want. So that's the idea. And I'd like to do this maybe being able to search for exact city names, or maybe even because sometimes that's difficult for a city like Sault Ste. Marie. How do you spell Sault Ste. Marie exactly? I don't know. I can spell the individual words, but I don't know if there's hyphens between them, and or spaces, or who knows. So it'd be nice to also have a sort of fuzzy search feature which lets you search maybe by substrings. Okay. So last class we looked at memory models, and where things live in memory, but we also looked at these objects. So we started to study object-oriented programming. So here I'm asking to make an application and maybe use this object-oriented paradigm. So what are the natural objects in this particular application? I can think of two. What are the natural classes of objects? Yep. City seems like a very natural class of objects. It looks like we have about 3 million different cities, so it seems natural for us to make that a class. What else? Yeah. Country. We have two files, one with a list of cities, another one with a list of countries. So it seems natural that we could make two kinds of objects, cities and countries. And I've told you what I hope to have in the end. It's an application where you can type in city names and it'll tell you information about those cities. So that's sort of the grand vision of this thing. And something that many people struggle with, and I see this all the time, it's what people come to my office, they say, I don't know where to begin. So we have to begin somewhere. And so let's start with a simple thing, or maybe one of the simplest things. So cities actually look fairly complicated. They have like two different names, latitude, longitude. Maybe they have a population, maybe they don't. As well, they've got a country associated with them. Whereas countries are fairly simple things, at least in this application, because, if I just take a look at it, a country has a name, and it has a couple of codes, a 2-letter code and a 3-letter code, and a numerical code. So let's focus on the countries first. And for this application, I'm definitely interested in the name of the country, because that's the kind of thing that I would like to show the user. And I'm also interested in, especially, this 2-letter country code, because if I look in the CSV file for the cities, it goes by 2-letter country code. Okay, so I'll need to be able to look those up that way. So let's just start really roughly and say, let us start making a class. It'll be called country. And what's the thing that every class should have? What's the function that every class needs in order to even make one? Yeah. What? Constructor? Yep. And in Python, so it's a method called a constructor, and in Python, that's a method which is called underscore underscore init underscore underscore, and it always takes, like all of the methods for a class, the first argument is always this special argument self, which in this case is the country that we're constructing. And then it can take any number of parameters, whatever ones you want. And maybe for us, we will say the parameters are the name of the country, the 2-letter code, and maybe the 3-letter code. And often in these data-driven applications, the constructor is fairly simple. All it does is it saves those relevant parameters. So with each country, we will save its name, we will save its 2-letter code, and we will save its 3-letter code. Okay. All right. So we have a country and a constructor. And we can test. Okay, so let's say C is equal to a country, Canada, CA, CAD. I don't even know if that's the correct 3-letter code for Canada. Oops. Don't forget to go into interactive mode. Okay, so there is indeed a country there. Its name is Canada. Its code is CA. Its 2-letter code is CA, and its 3-letter code is CAD. So that seems to work. What else? What's the next thing we can do here? So I don't know yet how to build the whole application, but I can think of things that might be useful. What could we do next? So you can name anything that you think might be useful, and we can do it. What's that? Capital city. Well, first we would need city. So anytime you think of doing something, what could I do? Think of, is there anything that I need to do before that? So right now, the only thing I have is a class for countries. So if I want to do capital cities, what do I need to do first? What's that? So I should have a class for what? City. Okay. So let's make a city class. So create a new type of class of objects called city. All right, so what are the things cities have? Well, they have a name. They have, let's take a look in our file again. So they have a name. They have a country associated with them. Okay. They have possibly a population, and they have a latitude and longitude. So let's see. Country, latitude, longitude, and maybe a population. And so, like most of these constructors in these data-driven applications, the main purpose of when we construct it is just to save this information. So we'll save the name, save the country, save the latitude, longitude, and save the population. Okay. And we can test that. So the name of the city can be Ottawa, the country can be Canada, the latitude is, I don't know, anything you want, and let's say the population is 1 million. So C is a city object, and indeed it has the correct name. It has the name of the country we assign to it. It has a latitude, it has a longitude, and a population. Okay, so now we have a city object as well. What can we do now? Now we've created a city object and a country object. They're able to store the information about themselves. What next? You can suggest anything as long as it's getting us a step closer towards this goal of building this application that does what we want. What's that? Why create a string function? To do what? Oh, I see. So we can get a more meaningful representation of it. Sure. Should we do that for cities or countries first? Let's do it for country first, because I guess it's going to be an easy one. So let's say I want to see what a country looks like. Well, it has a name and a 2-letter code and a 3-letter code. Maybe just the name is a nice representation of the country. So when I want to convert a country to a string, well, what I'll do is I'll just return the name of the country. Now, cities, maybe we can do something more interesting. So usually when someone says a city, maybe like on an address or something, they might say something like Ottawa, Canada, and maybe the population. I don't know. Is that a reasonable representation of a city? I mean, usually the latitude and longitude, you don't need to see it every time you print the city. So let's say name of the city, comma, name of the country, and then the population. So let's say S is equal to name of the city, name of the country, and if we have it, we'll do the population, but we saw from the file that we don't always have it. So let's say that will be self.name, that'll be self.country, and if we have some population, then I'll say S is equal to S plus okay, and then finally return that string. All right, that was a fair bit of code. Let's quickly test it out. Oops. So there's our city. The representation, the internal representation of it, we still don't see anything interesting, but if we print it, we see Ottawa, Canada, population 1 million. So that looks good. And I could also try making a city where I don't know the population. So I don't know, maybe that's 0. And if I print that, I just get Ottawa, Canada, or maybe the population was the empty string, Ottawa, Canada. Okay, so already one little lesson there. In this thing, I put an if statement that said, if self.population. Now, population is supposed to be an integer, and so I'm saying if an integer, then do something, otherwise don't do it. Does anybody know what that means? It's like, literally this sounds like me saying, if 10, then do this. Yeah? Yeah. So in Python and in many other languages, every object can be converted to a Boolean value, a true or false value. And how that conversion happens depends on the kind of object it is. But if the object is an integer, then there's an easy rule. Yes? Yep.
Since we already have that string method, why wouldn't we just typing just C into the terminal?
Because typing just C returns the Python representation of the object, which is the thing that you see. It's supposed to be something like, really it should be Python code that would allow us to construct the object, but we never defined it. So it just shows us some information about this object internally. It's like the programmer's view of the object. Whereas printing it shows us the string representation of the object, which is kind of like the external thing. If we want something more interesting, and it's very helpful for debugging to have something more interesting than this, we have to define this method, which we did last class as well. It's called the repr method. It stands for representation, and usually it's actually quite ugly and quite boring, but I'll do one example for you. And you'll see a lot of stuff there. So it's supposed to return a string, and the string in a perfect world will actually be valid Python code that recreates this object. So to create this object, I should call city, and I should pass it a bunch of arguments, which are the name, the country, the latitude, the longitude, and the population. And so that's self.name, self.country, self.lat, long, and self.population. Okay. Let's make that city again. Now if I look at C, I see something more meaningful, right? Now, this isn't quite what repr should do, because this isn't valid Python code. If I try to copy and paste it, well, I get a mistake that says, I know what it knows what city is. It's that class, so it's trying to construct it, but it doesn't know what Ottawa is. In fact, if I was trying to make a city called Ottawa, then that thing should be a string. And Python's string format method has a neat thing that helps with this. So we discussed really, really briefly that when you use string format, there's these curly braces, and there's all kinds of stuff you can put inside those curly braces to say how to print things. And one of the things you can do is put an exclamation mark and an R, which means show me what you should print here is the internal Python representation of this thing. So if I do that, then I get exactly what I want. Okay. So that there is actually a piece of Python code that I could just paste into Python and get exactly the same city back, or as close as possible. Okay. These things usually they're not strictly necessary defining this repr method, but they're helpful for when you're debugging, basically, to inspect things just like we're doing now. Okay. So I was talking about this weird if statement that says if self.population. So I was saying that every kind of object, every kind of data in Python has a way of converting itself to a Boolean value, true or false. And it depends what kind of data it is. So integers, the rule is very easy. If the integer is 0, it's false. Otherwise, it's true. If it's anything other than 0. For strings, if the string is empty, meaning it has 0 length, then it's false. Otherwise, it's true. And the sort of most common thing is Python has this value none, which is in other languages would be called null or nil. That's always false. So in this case, if you give me a population of 0, or if you give me a population which is the empty string, or if you give me a population of none, then this method won't print it. Otherwise, it will print it. It'll include it in the string method. Okay, so we have countries. Well, I don't know. For completeness, let's do a representation for countries as well. So for that, we return a string which calls country, tells me the name, the code 2, and the code 3. So, let's do it this way. Can is a country called Canada, C-A-D. If I look at can, there it is. If I print it prints like that. And if I then define Ottawa, let's make that Ottawa is a city. Ottawa, and its country is Canada, the object Canada, and I don't know, it has a latitude and longitude, which I don't know, and its population is, let's say, 1 million. And if I look at Ottawa now, I see that it's a city. You can see that these kinds of things sort of build on themselves. What's the representation of Ottawa? It's a city that I can create by calling the city class with the string Ottawa, with this argument with the country that I can make up by this way, and then the latitude and longitude. Okay? So these things can get very big, but actually what this is a piece of Python code that will build this city, and in fact, as part of building this city, it'll build this country object that is Canada as well. Okay. All right. So, what next? So we have some reasonable country object, some reasonable city object. How do we get further towards our application? Yep. Yeah, so we want to somehow use these things. So what do we have? On one side, we have this CSV file where every line is a string representation of a city, and inside our program, we have these city objects. So I think what we want to do is read each line of the CSV file and use the data that's in there to create a country for that represents that thing. Okay? So here's a bit of code that opens the countrycodes.csv file and opens a reader on them. And now I want to go through each line of that file, so each row in that CSV file for row and reader. And what does a row look like? Well, it's an array, and the first thing should be a string, which is the name of the country. The second thing is a two-letter code. The third thing, so the 0th thing is the name. The 1th thing is the two-letter code. The 2th thing is the three-letter code. And those are the things that I need in order to make a city, right? Or sorry, to make a country. So what I want to do is make a country, and the name comes from position 0 in the row. The two-letter code comes from position 1, and the three-letter code comes from position 2. So that'll create this country, but I don't just want to create it, I want to save it somehow. So maybe I want to make a list of all of the countries that I have. So let's try that and say countries is equal to a list. And each time I read a row in this file, I say countries.append. And at the end of this process, I return countries. Country is never defined. Countries.append. Okay, so something happened there, and if I look, yeah, there's some code in here that calls load countries. Load countries creates this big list of countries and returns it, so we should now have a variable available to us called countries. Let's see. Yep, there it is. Let's look at some of the entries in countries. The first one is a country, the Åland Islands. Country code is AX, and the two-letter code is AX, and the three-letter code is ALA. There was something like 250 lines in this file, so we should be able to ask for maybe, what is the 200th element in this list? It's Sudan, SD, SDN. Okay. So we seem to have gotten all of the countries in a big list. That's kind of a important thing. We're going to need that. But now we've got that CSV file, and we turned it into a bunch of objects, a big list of objects. What's the next natural thing to do? Well, we're trying to make an application that searches for cities by name, and so we don't have a list of cities yet. So maybe the next natural thing then is to make a list of cities. All right. But maybe before I do that, I'll just show you one little thing. So let me just comment out this here is this is the long version of this load countries function. And there is a shorter way to write this, because if you look at what we're doing here, it's following a fairly common pattern. We create an empty list, and then we have this reader, and for each row in the reader, we append something to our list that depends on that row. And then we return that list of all of these things. So have we seen a shorter way of doing this kind of operation? You have a sequence of things, and I want to convert it into another sequence where the elements are related in some way. Like the first element of this sequence becomes something else in the second sequence. It's a really common pattern, and so common that Python has a construct for it, and it's just the list comprehensions that we've seen. In fact, all we have to do is say, what I want here is a list that contains country, lines of code are just disappearing everywhere here. I want to return a list which contains the country that I get by taking a row and using these three things as its arguments. And I want to do that for every row in the reader, in the CSV reader. So all of that really is just one line of code. So this reader here, it's not a list exactly, but we know it's a thing that you can write a for loop that iterates over, because we've written a for loop that iterates over it. So it's actually some kind of sequence that we can iterate over, and that means that we can use it in a list comprehension like this. Okay. So this code does exactly the same thing as this longer version of code, and I think in a somewhat more clear way, because everything is gathered up in one place. It says, give me a country made this way for every row that's in this CSV file. Let's just check that already. Yeah. So that does exactly the same thing. This is a shorter version. Okay, now we want to do something similar for the cities. All right, so the cities are more complicated, and we'll have to be careful to somehow deconstruct them in the right way, because what we've got is our CSV file. So let's look at the first two lines in World Cities Pop. So I've got a country code first, that's at position 0. I've got the city name at position 1, or the strange city name at position 1, and then the longer city name at position, the full city name with all the accents at position 2, and then the rest of this stuff. So let's carefully do this, and we'll follow the same pattern we used here. So we want to make a city, and when we make a new city, we need, somebody remember this, name, country, lat, long, population. So the name of the city is at position what here? 1 or 2, depends which name you want, whether it's the lowercase name or the one that possibly has accents and uppercases. Let's take 2 for now. Maybe we'll have to rethink that later. Okay, I've already forgot what the second argument was. Name country.
0.
Country is at position 0. Lat, lon, and population. Okay, so let's count those out. 0, 1, 2, 3, 4, 5 is lat, and 6 is lon. 5, 6, and if we want the population, it's not at 0, not at 1, not at 2, not at 3, it's at position 4. Okay. And let's see if we got it right. So what's going on here? Why am I not able to type? Why was there a pause there? Why wasn't it instantaneous like it always is? Just loaded 3 million cities. Let's hope it did the right thing and all that work wasn't for nothing. So we have a list now with 3 million cities in it. And if we look at position 0, we've seen that one before. It's this city whose name I can't pronounce. It's in this country whose code is AD. And it's got a latitude and a longitude and possibly a population. All of those things are stored as strings. Maybe I want that, maybe I don't. For this application, we're not going to be searching geographically by latitude and longitude, so we can leave those as strings. And the population even as well, that's not going to hurt anything, I don't think. So what happens if I print cities at 0? That looks fine. And let's take a... I guess the problem is if we pick a random city, it's probably most likely to be small and not have a population data associated with it. So we're not going to find too much exciting stuff here. All right, is that really what we want for a city? So if I want to print this city, New Dugga, where's New Dugga? NG. I would guess New Guinea, actually, maybe Papua New Guinea. But it's not really useful to me this way, right? And why is that? Well, because I created this city, and the country that I gave it was that first item in the CSV file, which is a 2-letter abbreviation for the country name. And that's not really what I want. What I would really like is maybe the name of the country, or maybe even the country, like the country object that I've already created. Okay? So when I load the cities, maybe you should also tell me what the countries are so that I can do this conversion. So let's try that. So when I load the cities, you give me the list of countries. And here, I want to find out which country, so row at 0 is the country code, and what I would really like is the actual country. So I want some way that you give me a country code and I get back the actual country. What kind of thing in Python handles that kind of job? Where you give me a code or a key and I get back a value.
Dictionary?
Yeah, a dictionary. I would like a dictionary where the keys are the country codes and the values are maybe the string representation of the country or maybe just the country itself, the country object. Okay, so I have this list of countries and I want to turn it into a dictionary whose keys are the country codes and whose values are the objects themselves. So let's see how we could make one of these things. So back in the interpreter here, I've got this list of countries. And I would like to make, and I'll show you again, another thing which is just a little bit of icing on the Python cake. Not only can you do list comprehensions, but you can also do dictionary comprehensions. And let's do one. So I'm going to say make a dictionary, call it D. And it's going to take each country and take its 2-letter code, and it's going to map it onto the country itself. And it's going to do that for every country in my list of countries. So if I do D at CA, I get Canada. D at this mysterious country NG, Nigeria. I was wrong. At NL, I get the Netherlands. Okay? So here is a dictionary comprehension that adds, and the syntax looks like this. You want to add the key value pair where the key is the country code, a 2-letter country code, and the value is actually the country object itself. And the syntax is you just put a colon between those two things. That means the pair, and you want to do that for every CN countries. Okay? So we have a piece of working code that does that. We'll put a comment. Convert from country codes to countries. And instead of row at 0 here, we want D at row at 0. And now, we changed our function load cities so that it accepts an argument called countries. So we'd better pass it that argument. And then we wait a bit while it loads these 3 million cities. And what happened there? Anybody tell me? So I get an error message that says, okay, I had an error in this function load cities, and here's the line where it happened, and the error is key error me. So what do you think happened? Yep. There's no country in the dictionary that has the key me in it, or there's no country. There's no country in this file whose 2-letter country code is me. Okay, so now that's a little bit annoying. So that means our data is incomplete. We could try and clean up the data, or we have to go the long way, and I guess that's what we're going to do. And we'll do the following. We'll say cities is a list, and then we'll say for row in reader, and the country code is row at 0, and we can say if the country code is in the dictionary, then we say cities dot append this thing. And so this is a test to see if the country code for the current row is actually in our dictionary, then we know what to do. And what should we do if the country code is not in the dictionary? Should we just throw that city away? Ignore it? Yeah, let's do that. See if that works. I mean, that's the sort of safe thing to do. All right, and so I've got countries, and let's look at countries at or cities at 200. Because I changed the way this code works, I shouldn't forget that I have to return this list of cities that I created. It's not just a one-liner anymore. Right? So cities at 200 is Bidyarat Margam in the country United Arab Emirates, and there's its latitude and longitude. And if I print cities at 200, this is what I see. And already, if you work your way through this, you'll see that there's some really interesting things happening here. When I print a city, that entails converting it to a string. Well, what does the conversion to a string for a city do? Well, it takes the name of the city as well as the country. But that country is actually a country object. And before that country object gets, that country object is then converted itself to a string. And so, right, remember this thing, right, if I look at cities at 200, it contains a country object. And when I convert the city to a string, that uses the string, which is the name of the city, and then the country, it converts that to a string, which calls its own string method that converts the country to a string, which just gives you the name of the country. So a lot of things are happening here, even in just this call to print cities. Okay. So now we have our data. It's all loaded up. So now all we need to do is, we've got all the data we need. If somebody asks us to search for something, or we have it in memory, ready to go. So now it's time to put the face on this application. And it's often the case that for these applications, once you get to the application itself, things suddenly start happening fast. Like right up until this point, nothing appeared, nothing happened at all. You run this program, it loads some data, and then nothing happens. And now suddenly we'll be able to do everything all at once. So there's kind of a eureka moment when the thing starts working. It goes from nothing to actually looking like an application. Though throughout the whole time we've been testing things and making sure that stuff loaded correctly and so on. But from a user's perspective, what we've done so far is useless. Now it's suddenly going to become useful. Okay, so let's say query is input enter a city name. Okay, so and we can run this thing now. Okay, somebody give me a city name. Any city name? Vancouver. Okay, so there's my query, Vancouver. I know that I have a list of cities. It's called cities. I won't show you the whole thing because it has 3 million cities in it. So, and sometimes it's really helpful to work this way. At the Python interpreter, let's write the code that's going to give us what we want, and then we'll be able to just copy it over into our program. So I have a list of 3 million cities, and I want to get a list of all of the cities whose name is Vancouver. How do I do that? I have a big list, and I want to get only the elements in that list that satisfy a specific condition. What's the standard way of doing that? An if, there will be the word if will appear in the solution. I mean, I could iterate through the list of 3 million cities and then check each one, and if it satisfies the condition, append it to the list, and at the end of that process I'll have the list. But what's the short way of doing that? It's a list comprehension. So I want all of the cities. I want every city C that's in my list of cities, but only if c.name is equal to query, Vancouver. So who thinks this is going to work? There you go. There's our list of cities whose name is Vancouver, and maybe surprisingly, or maybe not, how many cities are there called Vancouver? There's 2 of them. First one is in Canada, and the second one is in the United States. Okay. All right. So now I know how to get the result for my query. It looks like this. And now it's just a question of printing the results for C in results. For each city in the results, print C. So let's try Ottawa. many cities named Ottawa around the world. Canada, Indonesia, and a whole bunch of them in the United States. So something looks maybe fishy or not so much fishy, but we're somehow missing some information here. So let's take a look at, back in our file, let's look for Ottawa in worldcitiespop.csv, and maybe we'll see something. Here's the entry for Ottawa, Canada. Here's the entry for Ottawa, Illinois. Here's the entry for Ottawa, Kansas. So it looks like there's a little extra piece of information in this CSV file that we haven't been using. And unfortunately, it's not a particularly exciting one, or in many cases, it's not particularly useful. It seems that there's, at position 0, 1, 2, 3, there's a region that tells us which region of the country this particular city is located in. In the United States, those regions are meaningful. In Canada, it seems there's something like 12 of them, and they're assigned the numbers 1 through 12. But I don't know what the mapping is, although I could figure it out, I guess. And probably in other countries, there's maybe no such regions at all. But maybe we could include that in our information, just so we see something a little more interesting. So we've got countries, our cities, they have a name, a country. Maybe inside that country, they should have a region. It's there, we might as well save it. And then when I print one of these things, maybe I want to say something, do it like this. Right, so Ottawa, Ontario, Canada. Okay, and name country. Okay, and when I load my cities, I'd better include that argument, which is, so we got name, country, region, which is a row at 0, 1, 2, 3. Maybe this will work. Let's try. Didn't crash yet, that's a good sign. All right, so now we're getting some really meaningful output. We get the name of the city, the region, whatever that is, and the country, and the population, if the population data is known. All right. Now that, I mean, we're almost there, right? We almost have our full application now. Now it's just a question of polishing. So one thing that is a bit strange maybe is it's kind of already, it takes like 3 or 4 seconds to open this file and read it, and then this application asks us one query and then it's over. So maybe if we're going to go to all that that overhead of reading the whole file, maybe we can let them ask more queries. So we'll do something like while query, enter city name and blank to quit. And as long as the user enters something, so while we have a query, so while the result of input is not, when treated as a Boolean value, is true, and the result from input is actually always a string, and false, the only string which is treated as false is the empty string. So if the user presses enter, we get the empty string, that's treated as false, and this thing will quit. And now we can ask this question. Okay, somebody give me a city name. What? Stockholm. Lots of Stockholms. In fact, even in Sweden, there are 3 Stockholms. And the United States is not the most original country with naming cities. That's one thing you can learn from all of this. Give me another city name. New York? New York. There's one in the United States, also in Honduras, 2 in Jamaica, Mexico, and a whole bunch more in the United States. London. Ton of Londons, probably going from the fact that the United Kingdom liked to colonize places in the past, so there's some history showing up there. Another one. Moscow. Incredibly, given the historical relationship between the United States and the USSR, there's Moscows everywhere in the United States. Another one. Saigon. 2. Paris. Wow. That's impressive. Yeah, 2 in Canada, a couple in Congo, a couple in France, Gabon, Haiti, Indonesia, Turkey, Tomo. Again, probably to do with historically the way the French Navy kind of explored the world at certain points in history. Something else? Georgetown. Tons of Georgetowns. And that's probably just because George is a common name and maybe even more common among explorers. Anything else? Let's try Sault Ste. Marie. So there's one in Canada, but my guess is there's probably more of them just with slightly different spellings, right? Like maybe there. How about town that I come from? Don't see it there. No, there it is. No population data because it's such a small town. Anybody else want to give me their hometown, see if it's in there? Napanee, for sure. Also available in the United States. Transylvania or Pennsylvania? Transylvania. Related to that, no town named Stoker, but Brampton. Lots of Bramptons. No Worcestershire. Lots of Leicesters. Okay, so lots of towns. So we had our eureka moment where we went from nothing to suddenly something you can play with and explore. And now it's just a question of doing a bit of polishing. Like this, there's a few things that I've been very careful to do here while playing with this or while using this. I carefully capitalized everything appropriately when I did this, but maybe that's not something the user should have to do. I don't expect that Google is going to give me different results if I type poker with a lowercase p or poker with an uppercase p. So that we can fix by taking whatever the name of the city is and whatever the query is, and making them both lowercase. So that makes it a bit more robust. Okay, so just check that it works. This is Saga. Okay, so that works. But can we do better? Can we do more? Yeah. Yeah, so let's try and do something slightly more sophisticated. And this is where, yes, we had our eureka moment, and now we can go to really finely polishing, but let's write a function which we'll use to determine whether the city name and the query matches. Okay, so rather than wrap that all that logic up in there, we will write a function called matches, which takes the query and the city name and checks to see if those two things match. So let's try, something simple first. Let's say words is city.split, and we'll return true if the query is in words. So the city name has many, the city potentially is a bunch of words like Lac Ste. Marie or Sault Ste. Marie. We'll split it up just into the individual words, and if the query is one of those words, then we'll treat that as a match. But maybe before that, we should deal with exact matches because we don't want to break that. If query is equal to city, then we'll return true. But otherwise, if we can find the query anywhere in the list of words for that city when we split the name up, then maybe we'll also return true. Oh, and I should have done. Convert them both to lowercase before we start. So one of the annoying things about working with big data files is not only does it take a long time to load them, but then it also takes a long time to quit Python when you quit. Okay, so let's see. All of the cities with Mary in their name. And there's a mistake, which is true is spelled with a capital T. List of all of the cities with the word Mary in their name. And a whole bunch of cities named Jeff, including one named Jeff Davis. Okay. So there you go. In the span of this class, we went from 0 to a reasonably complete application that loads data, that answers as many queries as the user wants, and then exits when the user wants to stop. Okay. And that took us the time we had today.